Yeah, hello, everyone. I'm Yan. I'm a senior machine learning scientist at Wayfair. Thank you for attending this session. Today, I'm going to talk about one of our work, contextualization multi-arm Bandit for the email layout recommendation. So this is a joint work with my teammates, Emilian, Linas, Preston, Akash, Benjamin, and Matt. This is the outline of the presentation. I will first talk about the problem that we are trying to solve. Then I will share the approach that we try to solve this problem. After that, I will share the results we got from a series of the offline experiments before concluding the presentation. So as a quick intro, Wayfair is an American e-commerce company. We are focused on the furniture recommendation. A key part of our operation includes sending millions of emails to our customers daily. So these emails update them on the latest products or events that we have. It's likely not surprising that each percentage point increase in the response rate to our emails will lead to an increase in the sales or the customer activity. So we set off to tackle this problem to improve the response rate on our emails. To try and improve the response rate, we have this working hypothesis that is personalizing email content can improve the relevancy of the emails, and this encourages customers' interactions and improve the response rate. One important note to call out, it is common for the marketing emails to be generated from predefined email layout templates. For us, we have a set of predefined email layout templates. As we plan each email campaign, the products and events that we would like to, we hope to market to our customer will incorporate into this predefined template and then generate the final email, then send to our customers. So in this work, we are looking to personalizing marketing emails by choose an appropriate email layout template based on the receiving customer. Before I go on, it could be helpful to show this visual, which explains what an email layout template could look like. So in this case, we have an email layout that allows us to showcase 12 products and 6 marketing emails in an email. So the table on the right shows a relevant placement of each product or event to each other. So for these 12 products and 6 events on the left-hand side, we would compose them with an email template to get the eventual email on the right-hand side. We decided to tackle these problems with the multi-bandit approach. So each of the bandit represents a specific email layout template. We also use a D-dimensional vector to represent the receiving customers of the email. So what are some of the features for our model? So for each of the customers, we make use some customer demographic features, for example, like the age, gender, and also we use customer behavior-related features, for example, like the how many days since this customer last viewed the product or ordered our product, or maybe click email. And also we have some email layout template related features, for example, like what type of this template. In terms of the actual machine learning model, we make use of XGBoost as a binary classifier. So for each customer, the goal is to predict whether they will click on the email. So why we choose the XGBoost here? Because it is generally performs well, and also it is comparatively against the many state-of-the-art models. To make the problem tractable, we adopt an epsilon gradient approach to balance between exploration and also exploitation. So we gave 5% of the time, instead of using the email layout predictor by our model, we will choose from a uniform distribution of all email layouts. So this diagram shows the pipelines that we have. Here, the green box represents our data collection component, while we assemble the data we need. And the yellow box is our data preprocessing components, where we collect the features we need and also transform this kind of features into the appropriate vectors used by our XGBoost model. So training is done daily, while inference results are logged and tracked, and also included into the next day's training. So having seen the approach we are using, so let's talk briefly about the data set that we are using before diving into the results. So for this work, we collected click data for a total of 38 days. So from September 10th to October 17th last year, we carved up 4 weeks for the training and validation, while keeping the remaining 10 days of the data for the evaluation purpose. So in all, this data is composed of about 600 million data points, and each data point includes anonymous customer features and also the template layout that the customer viewed, and also any click actions on the links within the email. We did a series of experiments, including offline evaluation, off-policy evaluation, and also online A/B testing. So here, I introduced the offline evaluation. Basically, we evaluate our model on 2 data sets. The first is some data from the same training period. So that is a held out set. And another one is the testing data. Basically, that is from the remaining 10 days of the testing period. So overall, we can see that the performance of the classifier is pretty stable across key metrics, including F1 and also AUC. So this is there is a slight degradation as we tested the model over the testing period, but this is expected since the training data would get stale with some passing day. So overall, the results looks promising. As a next step, before we start full-fledged A/B testing, we did an off-policy evaluation. So in this evaluation, we try to use some estimator for the click-through rate, or CTR, we call CTR. So we choose to do this with SNPs and also the recap. When compared with the current click-through rate of our current system, so here you can, from this picture, you can see that there is a white circle. That is the mean of the CTR. So from this picture, we can see the SNPs and also recap suggested that our model would be able to result in a little higher click-through rates. And for the recap, we want to see it estimate the CTR very well in practice. And also, we find that is works very well on the large space arms. So this is another positive signal that our model is working as intended. And with the confidence we have from our offline evaluation and off-policy evaluation, we conducted an online A/B testing. So we have about 90 million users in each of the lanes. One is for the control, one is for the treatment. After our testing, A/B testing period, so we see a 1.2% increase in the CTR and also 2.3% increase in the conversion rate. and a reduction of the unsubscriber rate. So we know that CTR is an important business metrics, and also for the conversion rate, that often tracks how many of the customers go from viewing a marketing email to actually performing a buy action. So, and also for the unsubscriber rate, tracks the rate at which customers are churning from our marketing emails. So this is an important guardrail metric for us to check, because once customer churn away, so we have very limited levers and ways to attract them back into our email list. So the system I have described is launched and living in our production right now. So with that, we have come to the end of this presentation. To recap what I talked about, we focus on the problem of email personalization. Our hypothesis is doing this will increase the customer engagement within our emails. So we also frame this as a multi-unbounded problem and build up a system using the epsilon gradient strategy to solve the problem. And we tested our approach extensively through a combination of offline evaluation, of policy evaluation, and online A/B test. And we showed that we are able to improve the top-line business metrics, including our click-through rate, conversion rate, significantly. Yeah, thanks for your time and attention. We have some time for questions now.
Thank you. I would like to remind you that if you have questions and you're in the audience, you can approach one of the microphones, or otherwise you can ask your questions on Slido. I see there's a first question from the audience.
Hello, thank you for your report. My name is Alex. I'm from RAC 10. And could you please explain how exactly did you transfer the concept of bandits into the XGBoost? Because it seems to be some kind of novelty here, but I didn't quite get it. How exactly did you do it?
Yeah, I think this is a very good question. I didn't give too much details on how to incorporate the XGBoost with the unbounded strategy. So basically, you can think about the whole framework is an epsilon gradient approach. So for example, when we do the exploitation, so we will call the XGBoost model. So that is for example, when we do the online inference, we will using this XGBoost model to predict the score of a template. But how do we do the training? So I think for the training part, as I mentioned, we use the click-through rate. So basically, for each of the customer, we know which template the customer clicked. So basically, based on this data, we train one model. So that is you can think about that as a classification model. So basically, that is for the training part. So for online inference, I have talked, but for the online inference, we will do, like for all of the template, we will do the prediction, then choose the best one for the final template and send that to our customer.
Okay. Thank you very much.
Okay, good.
Okay, we also have some questions from home. The first one asks, is improvement in business metrics measured in relative percentage of absolute?
Yeah, that is a relative improvement because we compare the control with the treatment. So that is a relative improvement, not absolute improvement.
Okay, thank you. And we also have another question from home, which asks, how fast is the XGBoost model updated with respect to the user feedback?
So we train that daily. So we train that daily. So that means yesterday data will be included into the today's training pipeline. So with that.
Okay, thank you. I don't think there's any more questions, so I will probably ask a final one. So I saw that you used 3 strategies for evaluation. So you had like offline evaluation and then the A/B test. And so I was wondering if there was like any surprising results in between, like the offline, what you could you observe in the offline results, and then you could, for example, what you could observe online.
Yeah, so yeah, surprising results. Actually, before launch the A/B testing, we just observed that for the offline evaluation metrics and also off-policy evaluation metrics, we think maybe that is good, but we cannot sure. So, but for the A/B testing results, that is a surprising thing. It's like, wow, especially the conversion rate increased so much, so big. So, yeah, I would like to say this approach, although that is not like very complex model, but I would like to say that is a very practical framework, and also especially of policy evaluation part. So I think maybe other applications can use this kind of framework. So yeah, that is one of my recommendations.
Okay, thank you very much. So, okay, let's thank our speaker again. Thank you.